Welcome to Eureka Math. This is Module 2, Lesson 5, and our objective today is to connect visual models, and what they mean by that is area model. We're going to be working with area models today. And the distributive property to partial products of the standard algorithm without renaming. Okay, what they really mean is we are going to take expressions like, let's say, 31 times 122, and we're going to make them. We're going to put them into an area model. Okay, so in our area model, we're going to put the big number on top. You don't have to. You can do it in different ways, and here I'm going to put the ones here, and I'm going to put the tens here. Okay, so it's really 3 tens and 1 ones, but I'm going to write it as 31s. And then I'm going to multiply in my head these numbers. Okay, 1 times 122 is 122. And 30 times 122, well, that would be 3, 6, 6, 0. And I can do that in my head, right? And I'm going to connect that, so I'm distributing, right? So I broke this apart. It was 31, and I broke it apart. That means I distributed it. And I'm going to connect these to the partial products of the standard algorithm. So the standard algorithm looks like this, 122 times 31, which you should know how to do. Okay, so 1 times 2, 1 times 2, and 1 times 1. These are the ones, okay? This is the ones right here. So they want us to know, they want us to recognize how we're splitting these apart. Oh, excuse me. Okay, now I'm going to multiply times the 3s. So I'm going to add my 0 because there's 3s. I'm sorry, by the 10s because it's 10s. And 3 times 2 is 6. 3 times 2 is 6, and 3 times 1 is 3. Okay, so here I've got the tens right here. And if I take the 0 off, right, that 0, those are the tens. But I'm going to keep the 0 there so I know what I'm doing, so I don't forget it. And if I add these together, 2, 6, 7, 8, 7, 3, I should get the same answer in both my standard algorithm and in my area model. So here's 2, 8, 7, 3. Okay? And I got the same answer for both. That's what they mean. That's what they're talking about. Okay? So connect visual models, so the area model, that's the visual model that they're talking about, and the distributive property, that's splitting that 31 into the 1 and the 30 and multiplying it in different chunks. And we're going to connect that to what the standard model looks like, the standard algorithm, okay? And we're doing that because this is how we generally multiply 2-digit and 3-digit numbers. But this area model can help you see what we're actually doing, and that's why we're connecting those. Okay, so that is the objective. Let's go to the Learn book. Okay, name on your paper, draw an area model, and then solve using the standard algorithm. Okay, so my area model is going to be a big square, and I'm going to put the 34 on top and then 21 on the side, but I'm going to split this into 1 and 20. Okay, that's my distributive property right there. I'm going to break this apart because 1 times 34 is really easy to multiply. 1 times 34 is 34. And 20 times 34 is also pretty easy to multiply because 2 times 34 would be 68. And the 10 there is going to make it 680. And then adding 4, 11, carry the 1 is 714, okay? That was my area model. I multiplied the 1s, and then I multiplied the 20, which is also in the tens place. If I use the standard algorithm, which is how we multiply in general, they've already given it to us over here. Didn't realize, sorry. All right, what they want me to do, it says draw an area model and then solve using the standard algorithm. So we're going to do the same thing over here. 4 times 1 is 4. 1 times 3 is 3. So use arrows to match the partial products from the area model to the partial products of the algorithm. So there's this, right? Then we're going to do the next step, which is the tens. And I'm going to add a 0 because we're in the tens. 2 times 4 is 8. 2 times 3 is 6. And look at that, that's exactly the same. Okay? Then I add those together. 4, 8, 9, 10, 11. Carry the 1, 7, 14. 7, 14 is my answer. Not too hard. This shouldn't be hard. Okay? This area model is helping us break it apart so we can see what we're doing in a little bit of an easier way. Maybe use our mental math because we're using numbers that we know how to multiply now. All right? So here's another one. There is my area model. Put 434 on top. And then on the side I've got 21, but I'm going to break it into the ones and the 10 spot, so 20 and 1. 1 times 434 is 434. 20 times 434, well, 434 times 2 would be 868, and then put that 0 back on there, right? Because I can break that into 2 and 10, right? And if I add that all together, I get 4, 8, 9, 10, 11. Carry the 1 is 7, 8, 9, 10, 11. Carry the 1 is 9. 9,114. Okay, now I'm going to use the standard algorithm to solve the exact same problem. And I'm going to show you how this number should match here and this number should match here if I've done my job correctly. 1 times 4 is 4. 1 times 3 is 3. 1 times 4 is 4. Okay, perfect. Next is the tens, so I add a 0. 2 times 4 is 8. 2 times 3 is 6. 2 times 4 is 8. Okay, that matches perfectly. And now I'm going to add up my columns. 4, 8, 9, 10, 11. So 7, 8, 9, 10, 11. Carry the 1 is 9. The same. Next one. Now, we know how to use the area model, and if you want to use the area model, you always can. Please just show your work so I know what you're doing. But for number 2, it asks us to use the standard algorithm. And if you are still struggling with the standard algorithm, you need to come talk to me, all right? Because we need to get you help with that. 431, I like to always multiply with the bigger number on top, right? And then I'm going to multiply the ones first. So 2 times 1 is 2. 2 times 3 is 6. 2 times 4 is 8. Then the tens. 1 times 1 is 1. 1 times 3 is 3. 1 times 4 is 4. Then add them together. 2, 7, 11, and 5. Okay, so my answer is 5,172. Here's the next one. Bigger number on top, usually. 23 on the bottom. Okay, and I'm going to multiply the ones first. So 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. That's the 3, the ones place. Now I'll multiply the tens place, so I'll add a 0 because it's the tens place. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. And then I add those together. 9, 12, carry the 1 is 8, and 2. 2,829. Last one on this page, 312 times 32. Multiply the ones first. 2 ones times 2 is 4. 2 times 1 is 2. 2 times 3 is 6. Now the tens place. 3 times 2 is 6. 3 times 1 is 3. 3 times 3 is 9. Then add in a straight row 4, 8, 9, 9. Okay, 9,984. That is the standard algorithm. You need to be able to do that in 5th grade. If you cannot, you need to get some help. Okay. Number 3, Betty saves $161 a month. She saves $141 less each month than Jack. Okay, less than Jack. So Betty saves $161. Jack, right? So Jack saves 141 more than Betty. Okay, so Jack's is 141 plus what she saves, which is 161. She saves 141 less. That means he saves 141 more. Okay, less and more. Be careful with those. How much will Jack save in 2 years? Well, first let's find out how much he saves. Okay, 141 plus 161 is 2. Carry the 1 is $302 per month. How much will Jack save in 2 years? Okay, now you have to know how many months are in a year. So if he saves $302 per month, right? 1 month equals, 12 months equals 1 year. Then 2 years will equal how many months? Right? This doubled. So 24 months. Right? Now we want to figure out 302 times 24 to figure out how much he saves in 2 years. So I'm going to take that 302 and I'm going to multiply it with 24. Would you like me to use the standard algorithm or would you like me to use an area model? I think I'll just go ahead and use the standard algorithm because I'm all set up for it. 4 times 2 is 8. 4 times 0 is 0. 4 times 3 is 12. Okay, now I'm going to multiply the tens. 2 times 2 is 4. 2 times 0 is 0. 2 times 3 is 6. Okay, add those up. I have 8, 4, 2, and 7. That's a lot of money. In 2 years, Jack will save $7,248. So let's write that in a sentence. In 2 years, Jack will save $7,248. Okay, number 4. Farmer Brown feeds 12 1/10 kilograms of alfalfa, that's kind of like a leafy green, to each of his 2 horses daily. To each. So they each get that. So 12.1 to horse number 1 and 12.1 to horse number 2. Okay. How many kilograms of alfalfa will all his horses have eaten after 21 days? Okay, so horse 1 and horse 2, or horse A and horse B, and that's every day. So let's add that together. Remember, when you're adding decimals, you have to line up the decimal. So 1 plus 1 is 2, 2 plus 2 is 4, 1 plus 1 is 2. So that's 24 2/10 kilograms per day. Okay, now we want to multiply that number times 21. Okay, so here's what I'm going to do. I'm going to draw an area model to solve. And I'm going to put 24 2/10 on the top. And then 21 days I'm going to break into 1 and 20. Okay? So 1 times 24 2/10 is 24 2/10. Easy. 2 times 24 2/10 would be 48 4/10, right? 48 4/10. But I'm going to multiply this by 0. So I can't just add a 0 here. I need to actually move the decimal point over. And my new answer is hang on. Now my new answer is 484, right? On this answer, right? Now I'm going to add them together. Now remember, this is 0.0. So 2/10, 4 and 4 is 8, and 2 and 8 is 10. Carry the 1 is 500. 508 and 2/10 kilograms. Now I'm going to multiply with the standard algorithm just to check my work. And I know that we have not been multiplying with decimals very much, so just follow along. Okay, so if I have 24 and 2/10 times 21 days, I'm going to multiply 1 day times 24.2, which is going to give me 24.2. And then I'm going to multiply the tenths, so I add my 0. 2 times 2 is 4. 2 times 4 is 8, and 2 times 2 is 4. Then add those together. I've got 2, 8, 10, carry the 1 is 5. And now I have to put this decimal back in here. And in my answer, there's only one decimal, so I'm just going to put one decimal right there. And that worked. Okay. How many kilograms of alfalfa will all his horses have eaten after 21 days? His horses will eat 508 and 2/10 kilograms in 21 days. Period. Good. All right. And then that's the homework. So drawing those area models to help you understand what we're doing. Okay. This goes with this, and that goes with that. And we'll do the exit ticket in class. So have a great day. Thank you.